Hi everyone, trust you're doing good. All right, so imagine you're asked to balance this particular equations. We have the first one, the second one, and the third one. Okay, now first of all, balancing of chemical equations is one of the easiest thing you want to experience, right? Because it's just basically simple because it follows one principle, which we call the principle of conservation of mass. That is, you can neither create matter nor destroy it. That which means now, for instance, if you look at this Na plus Cl2 to give NaCl. There's a problem. Why? This is Cl2. This is Cl. That means we have two Cl here and we have one Cl. That means I've already destroyed matter. So the principle is that the principle of law of conservation of mass is that whatever is at the reactant side must be equal to the what? Product side. Or sometimes people say whatever is at the left hand side must be equal to whatever is on the right hand side. Okay, now let's delve into it. So Na, this is Na, right? Na here is 1. Na here is 1. Balanced. There's no problem with Na. But there's a problem with Cl2, right? Because you can see Cl2 here is 2. That is Cl gas. This is the way it exists. Here it is what? It is 1. So I need to balance it. Now, there are things you have to understand. The 2 here is called a subscript. We don't touch it. What is on this side is called moles, or sometimes some people call it coefficient. So the coefficient of this Na here is 1, coefficient of Cl2 here is 1, coefficient of NaCl here is 1, or moles. So now you only affect moles when we want to balance. You don't affect the way the particular that particular gas or substance exists. Now imagine as we have Cl2 here, imagine adding C2 to this place. There's a problem. I've altered this chemical compound itself. So now having 2 here means I should make Cl to be 2. And the only way to make Cl to be 2 is to add 2 here. Right? Now adding 2 to this place, there's a problem. Why? Cl is balanced, but there's a problem with Na. I've created a problem because I've created another matter. And the principle is that matter is neither created nor destroyed. That means I have to find a way to balance. The 2 that is here must come here. Don't forget, I will not add the 2 here because Na exists as Na, as monoatomic. So I will balance it here. So this is a balanced equation. How many Na is here? 2. Na here is 2. Na here is 2. Cl here is 2. Cl here is 2. This is a balanced equation. Very easy. Now, zinc reacts with H2SO4 to give zinc sulfate and hydrogen gas. Now, zinc here is 1. Zinc here is 1. No problem. SO4. No problem. Abi? H2. No problem. That means this is a balanced equation. You don't need to touch anything because if you look at it, zinc 1, H2, S1S, oxygen 4. So zinc here is 1, zinc here is 1, H is 2, H is 2, S is 1, S is 1, O is 4, oxygen is 4. This is a balanced equation. It must always be conservative. You don't destroy or create matter. Now, CaCO3, CaO, and CO2. Now, look at Ca. How many Ca do you have here? Ca here is 1. Ca here is 1. C here is also 1. C here is also 1. Oxygen here is 3. But oxygen here too is also what? It's also 3. This is a balanced equation. Very easy. I hope you understand this. So see you in my next video. Bye for now. Don't forget, it is the principle of conservation of mass.